This is AP Calculus AB question, and this one asks to find open intervals when the function is increasing or decreasing and find all local extrema. So to find that, I'm going to have to take the derivative. This is f. I'll just write it here. F is x minus 2. F prime is just 1. G is e to the x, and g prime is e to the x. So I'm going to use the power, or the product rule. I was going to say the power rule. So it's f prime g times plus g prime f. So f prime is 1, g is e to the x, so it's e to the x plus g prime e to the x times x minus 2. That's the derivative. And now I want to simplify this. I'll factor an e out. E to the x, 1 plus x minus 2. E to the x divided by e to the x is 1. E to the x times x minus 2 divided by e to the x is x minus 2. And 1 plus x minus 2 is x minus 1. So e to the x times x minus 1. And that's the derivative. And now to find, now this is continuous everywhere for all values of x, but, and I'll prove that, here's e to the x, and here's x minus 1. It's just continuous. And what does this question say? I have to look. Find the opening intervals with function increasing or decreasing. Check results with a graphing utility. Since it says check your results with a graphing utility, I can use a calculator. So this is never equal. I want to set this equal to 0. This is never equal to 0. E to the x looks like that, where it's got an asymptote at 0. So the only thing that matters is x minus 1 equals 0, x equals 1 is my critical point. So I'm going to do negative infinity to 1, 1 to infinity, and I'll use negative 10, and I'll use 10. Whoa, wait a minute, I can use 0. So I'm going to use 0, and I'm going to put it into the derivative, because I want to see if it's increasing or decreasing. So e to the 0 times negative 1. E to the 0 is 1 times negative 1 is negative 1. So it is decreasing. It's negative, decreasing. So from negative infinity to 0, it is to 1 rather, it is decreasing. And then from 1 to there, I'm going to use 10 e to the 10th times 9. Well, remember, e looks like this. So this is positive, 9 is positive, that's positive. The function is increasing. You can put that on your calculator and you'll see it's positive. So from 1 to infinity, it's increasing. And then it asks to find all local extrema. Well, since 1 is a critical value and it's decreasing before that and increasing after, 1 has to be a minimum. So 1 comma something is a minimum, and I'll plug that into the original function to find out what that is. 1 minus 2 times e to the first power equals negative e to the first power equals negative e. So 1 negative e is the minimum point. And then it says verify. That's how I know I can use a calculator. It says verify with a graphing utility. Well, I don't know of any other graphing utility I have than a calculator. I'm going to use Desmos, x minus 2 e to the x. And sure enough, there is my minimum at 1 and negative e, or negative 2.71828, and it's decreasing from negative infinity to 1 and increasing from 1 to infinity. So I verified it.